Alright, welcome guys. And I don't know if the audio is great. Let me just. Why the hell can't I hear anything? Maybe I shouldn't have this shitty game. Okay, so I will not waste my time trying to make the audio better because I simply don't know how to do that. So we'll just work with what we can. I hope that at least at least the sound is enough to Okay, so what we're going to do today is check out this TTS library that I always wanted to check out. Is this inference TTS inference engine, which allows you to run different text-to-speech models and output audio, basically like Llama CPP, but for text-to-speech. And what's interesting is that they support a lot of models. They support a lot of TTS models, and they claim to have a lot of improvements and optimizations in making these models run a lot more faster. So I'm talking about so let me see if we can. Let me just see if I can open. What the hell is this? I swear to you, this has never shown up before. I hope it's something to do with the fact that I'm streaming. I don't know. Yeah, so this is the project that I have been talking about, and for some reason the network is so slow. Maybe it's because I'm streaming. Right, so for some reason I'm using this Helium browser, and I haven't configured it rightly to save these my login details. But anyway, I'm not going to bother about that. So yeah, so this is the project, and they claim that models run significantly faster. So for example, white voice runs 5 times faster. Supertonic TTS, which is already quite fast, um, runs 6 times. So I'm not sure if these are um, comparing it with the default implementations. For example, Supertonic 3 has its own inference core that they have provided. So I'm not really sure if what they are claiming is 6 times of that, or if it's 6 times real time, because Supertonic 3 is already quite fast. And so we'll have to see that, because I'm not sure if it's much faster than what we already have. So for example, I have made a Supertonic 3 port into C# myself of the inference engine, and I have got significant. I mean, Supertonic 3 already had a C#, if I recall correctly, a C# library for inferencing, so I didn't actually port that. But I did port Pocket TTS, and I have to say I used AI to do that. But I remember I did not use AI to port the inference engine for the Orpheus TTS model. So for example, we had the internet is really slow. Alright, so this was Orpheus TTS, and I had written this, which was a C# engine for inferencing Orpheus model, and the main challenge of writing this was writing the snack decoder, right? And believe it or not, I did not use AI for it. Now, that's not because I did some insane stuff. I basically copied line by line the Python implementation of the snack decoder from here, right? And what made all of that possible was the C# library called as torch right? So you can see that I'm using torch as the torch replacement, right? Now, there were quite some challenges in doing that, because some functions that exist in torch for some reason does not exist in torch. So we had to get around doing some of those things, and surprisingly I did not use AI to do that, but I did use AI in porting the so I did use AI to port Pocket TTS again using Torch so that you can use it directly in .NET projects. Now, it already had an Onyx version, but what I found was that there were some deterioration in quality, and some it wasn't as smooth as using the native safe tensors from Qt. However, when I did port it using AI, in fact I used Gemini, it was more or less as similar to as the this implementation, the default implementation. However, I still had some. I still wasn't quite satisfied with the speed and some quite weird artifacts, such as repeated sentences or trails of gibberish sound, that kept on going, that did not end with the end of the sentence. So I didn't spend much time debugging AI generated code because, first of all, I don't think that's quite an easy thing to do. Prior, you have at least done something, because I just told the AI to do it entirely, and that was a mistake. But I just wanted to see if it can do it, and it did. It did work very well, and uh, for the time being, I was quite satisfied here. And it's even included in the official uh, repo of Qt's Pocket ETS, and here you can see this here. So I used yeah, so I think it wasn't fully AI. I mean, I had to do a lot of wrapping around sentence piece and all of the stuff. So I tried to steer it a lot because it doesn't work. At least Gemini, it doesn't work in the first run. So you have to do a lot of debugging in that sense. But I didn't dwell into the code and try to debug it to make the quality better, because that's something that I really don't want to do when the AI has done much of the core implementation. The AI implemented pretty much the entire encoder, decoder, all the surrounding stuff required to make this work. So since I haven't touched that at all, I simply don't want to go in and modify AI generated code. But what I want to do today is that if this this audio.cpp, which also has a Pocket TTS inferencer, there are lots of models that they support. So as you can see, they support Pocket TTS, TTS and voice cloning, in fact. So if they claim, if they are what they claim to be, which is that they have significantly made these TTS inferencing faster, then I would like to port it to C# myself, right? Because I checked how they are doing this inferencing, at least in the case of Pocket TTS, and as far as I have looked, they are using GGML. So I know that they also support CUDA GPU inferencing, but Pocket TTS works really well in CPU, right? And as far as I tried, my port, it works significantly better in CPU. I don't know why. I don't know if it has something to do with the shitty code that the AI wrote, or I don't know what it is. But I my experience running Pocket TTS was that it works significantly well in CPU. So I'm more than happy to have it run in CPU. And for CPU, they seem to be using GGML, right? And as far as I know, there is a GGML wrapper in C sharp, right? Which, so by the way, GGML is this C library which exports a lot of its functions. So you can basically call the functions that GGML exports using DLL import, right? You can use native interop in C sharp to call the library, and that is possible because GGML is something written in C. Now, if it was something in something else like in C++ or something, you'd have to have this some sort of C wrapper or I don't know. You have to create another DLL export which contains all the export definitions in C, and that's a whole another mess. But thankfully, since GGML is in C, we can directly use it. We can directly use it to have we can directly use all the functions inside the GGML DLL using native interop. And in fact, we don't even have to write the interop functions ourselves. In fact, this project over here already has it for us. So we have this file native.cs, and it has all the functions defined, right? So that's quite nice. We don't have to do any of that. Alright, so we just need to use we just need to have the ggml.dll of course for Windows x64 architecture, and it's I think provided by the Llama CPP distributions on GitHub. And we just need to use this file to rewrite, hopefully, audio CPP in C sharp. Now that's a plan. I don't know if it will be successful, but hopefully it is, right? Because I like products like this, which are based. They have their entire engine in C++, no Python dependency. And we are going to change C++ to C sharp. Now, theoretically, rewriting this entirely into C sharp would be a very major rewrite, because I don't know, I think it's quite unnecessary, because there's already this, and also you'll have to rewrite all the models, which I don't even want to think about, because I mean, and each of those models will have different implementations, different backends, and I really don't want to do that. But since we are just focusing on a single model, and we are not really even going to rewrite anything around the models either, I think it's perfectly doable, right? Because all we have to do is rewrite these files. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? That's what we have to do. And of course, I'll have to figure out how the inference actually happens, which is quite something to do because I haven't thought about it. But I think we can do that. So maybe it's not as easy as we think it is. All right, because I think we'll have to do a little bit of tinkering to figure out how this is actually going to work. Alright, so I think it's all pretty self-contained. Yeah. Wait a minute. So I guess I think I'll have to basically rewrite the entire thing because well, let's not get out ahead of ourselves, and um, let's try to see if this is actually fast as it claims to be, right? So let's just download this and see how it works. So I had actually downloaded this before, and oh, it looks like they have a new build or whatever. We are not going to run the CUDA one. That's 235 MB. Surprisingly, it was a lot bigger than this. I don't know what they did. Never mind. We're going to download the CPU balance one, right? We're going to do that. Okay. So I have already downloaded the Pocket ETS files, right? So we need these are the three files that you need to run Pocket ETS. It's the main model in the safe tenses format. You have the tokenizer, and then you have the embeddings, which are basically different voices. The one I like the most is the Jane one, which I think is quite expressive. And but one thing that Pocket ETS does not have is emotion tags. This was one thing that I really liked about Orpheus. So this Jane voice is quite similar in its how do I say, the texture of, say, the Orpheus model. However, it's not as expressive as the Orpheus. The Orpheus model can laugh, can sound sad, can do a lot of things, but and the way you can do those things is through voice tags. So say for example you need the model to laugh and between a sentence. You can add the audio tag for laughing and it will just laugh. However, you can do that with these models because for one, they are different architecturally. Orpheus model is actually much more like an LLM in the sense that it actually produces these audio tokens as its output. In fact, it's based on the Llama 3.1 3 billion or something model, and once it has produced these audio tokens, it puts them through the snack decoder, which produces the output. Whereas in the case of Pocket ATS, it's an entirely different chain of events that happens, and you can't really pass in because it's not really trained for Well, yeah, it's not really trained for processing emotion tags. It has not been trained with examples of, difference of the same sentences, different sentences, uh, with their emotions mapped, with the emotion attributes tagged with the sentences in the training data. So since that's not how the model works, you can't pass these emotion tags. But despite of that, this is really fast and uh, quite nice. I really like this TTS model. So I have downloaded these things and let's see. Okay, alright, so what I'll do is not run this, I'll just run this as. Alright, so alright, so if I recall correctly, you have to rename this safe tensors file as model. Hope I'm not wrong. And if I am, we won't be able to run this cycle. So so okay, so we need to pass in. Before we pass in the model argument, I remember that we pass in the task. And the task is TTS. And the model is the model directory, not the sequences, right? Right. And we can also pass in the text that we want it to say. So let's just say ETS, and we need a wave file. And we need the voice to be changed. Did not it failed? In that case, the files ggml assert. So there's something wrong with the ggml backend. Is it using let's see. Oh. Maybe I should just let's node or build. Yeah, so I think this was the one I downloaded yesterday. It worked. So I was right. There's something wrong with the latest build. Maybe I should file an issue, right? I just want to see what changes they made. Hmm. So maybe I will not dwell much on that. Uh, let's just hear how this sounds, right? So holy shit. I forgot to install VLC media player. Yeah, let's just custom settings. Finish it.
Hello from Pocket T. Hello from Pocket T.
Maybe it's not. Let's just.
Hello from Pocket TTS.
Alright, that sounds much better. So, as you can see, it's quite fast, but is it as fast as we want it to be? And I have been thinking about trying to measure this, measure the speed, and for that I will have to sort of build this myself, and that would be something interesting to do, right? And I haven't really programmed much in C++, to be honest. So it'd be really interesting to, yeah, it'd be really interesting to figure out how to do things, you know, and bring back some fond memories of programming in C++. To be honest, I'm not looking forward to that, if you know what I mean, but um, however, I think we can learn quite a deal about how this thing works by trying to play around with this thing. So since the latest commit did not really work, I'm not quite enthusiastic about cloning it in the current state. Maybe I'll just clone the one, just download, right? The one that works. Right, so I think it was this one. Let's get here. It's okay. Directly called as. All right. Oh my god, how big is this? Was it a mistake downloading this thing? What are they shipping the entire? What's so big in there? Like, why is it that large? Holy hell. It's still going. Freaking hell. Are they shipping entire Coda toolchain with this or what? Like, I hate when repositories do this. Like, I can almost tell that it is possible that they left some, they accidentally pushed some, I'm going to give them the benefit of the doubt because sometimes I myself do this thing because sometimes you accidentally, push a large file and you don't bother to clean that accidental push, which was totally unnecessary. Maybe you forgot it to include it in the git node or something like that. And it's a big mess to clean up afterwards. Yeah, but it's not that big of a deal, but all right. So I was supposed to just here. Just include right. Okay, so let's see if we can build this thing. Right? So just make sure I have all of these things. Right? I remember that we need the MSVC build toolchain, which has all the MSVC compiler, linker, all those good stuff. So we already have it. I think, yeah, I certainly have it in my main user, but I wasn't sure if I had it here. So it seems we do. So maybe I should run it there. Yeah, I think you just just execute this PowerShell script, and that's it, I guess. And we're not even building for CUDA, so we don't need to worry too much, I guess. Hmm. What? Maybe I'll have to run it here. With fucking future. No, this. Huh. Hmm. Maybe it has something to do with old the old version, the old version. I'm not really sure. Maybe I could just I think something is returning as empty. Not really sure why though. Hmm. I mean, I can't even see where the error is coming from. Like, clearly something is returning an empty string, or something is being passed. The argument name is being passed as an empty string, but I have no clue of which function is hmm. Holy shit. I guess you need to pass in these variables. Freaking hell. I just wasted 10 minutes simply because I could have just, yo, that has to be something else. Well, it's still throwing the error. Hmm. All right, so we are making progress. I think I know why this is happening, but I'm not sure if well, I actually have a couple of app locker rules that restrict these kind of script executions. So I'm pretty sure that's what's doing this thing. I think there's a way to override that, I guess. I'm not quite sure. Let's just see. But that's interesting. So this shows that well, this shows that I don't think, I might be wrong in the sense that this might not be because of um, you know using app locker rules, because clearly the script is running. Maybe it's because I have to prepend this to I guess it was running and I get the same error, which is saying, so let's just Supposed to be not name. Yes, so that's be there. Hmm. Wait a second. Hmm. Alright, so how long have you been streaming? Like, let me just check. Okay, so what is this supposed to be? Hmm. 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 Why is it not able to bind to an empty string? Like, that makes no sense. Like, hmm. Wait a second. One is not being covered, I suppose. Yeah. Hmm. Mhm. Wait. Hmm. Hmm. I forgot how to do the I think um, so hmm. Well, um, hmm. So this exists. However, mm, the native attribute is accessed. For some reason, it just doesn't work. So I guess there is. Also, why is it like then this never gets executed? That's very weird. Hmm. How about we call it and ask Claude? Like seriously, I'm not even. Clearly, this key exists. Like it's not that. Yeah, let's just do that. And I'm not going to spend my um, hmm. So I had to sign up. Sorry, sign in. I'm not going to do that. We'll just Yes, sensitivity. Oh, this is going. Yeah, what the hell? What the hell is I didn't understand. Really? Things, what else would it return? Get my holy shit. Wait, 30 minutes to debug PowerShell. I can't believe it. Like, you have to be kidding me. Like, I never thought I would spend 30 minutes debugging a PowerShell script. Yeah, I mean, honestly, that error was totally unexpected, and there would have been no way that I would have been guessed that it was my print statement, my echo, that was actually causing that. Holy shit. Well, so what's the problem with echo? Oh, who would have guessed? I mean, I always thought that echo was an alias for write host, not write output. I always used echo and write host interchangeably. Now I know that I shouldn't. By the way, what is the Holy shit, my CPU is throttling like. How are we reporting on the on our OBS? Surprisingly, not too much. The CPU is just sitting on 3.9. Yeah, I can clearly see the lag on my mouse cursor. Like it helps that this video is being sort of encoded using my GPU. I think that is why I was seeing a significant CPU usage, sorry, GPU usage. But yeah, I mean, hmm. So I'm quite curious. I think it's statically linked GGML. I think so. Or where is it actually? Or external? Hmm. Hmm. I think it's statically linked GGML CPU. Let's actually have a look at LD searching. Do we have LD? We don't. Well, I haven't. I forgot basically to bring in my LGW. Or do we have it here? So, how do I check? We could. Yes. Yeah, but I don't have the linker to check. Yeah, never mind. I think my assumption is correct that GGML has been statically linked with and also sentence space. Yeah. Well, sentence space I think was directly included. I don't think there was no need to link it, but GGML is certainly being statically linked. So how are we even going to measure the inference speed, right? Because so it's an engine. Hmm. Hmm. C++ projects. I mean, holy shit. Yeah, so this is what I defined. Good, good, good. So you know what? I think I can. It is pretty straightforward, I guess, to um just yeah input list C sharp. Like I just need to define the structs. Maybe even so what is this? So this seems to be a since you structs, I just need to possibly even have a sequential struct layout attribute, and it's pretty straightforward to do that. I don't think we have anything funny going on here. Yeah, it's going to take a while. Yeah, but before I do that, I need to really check the time, the speeds, right? So, where does the inference actually take place? Hmm. So basically, I'm trying to test TTS, right? So, distance kind. Right, so there has to be this function that basically takes in text. So I think we can get a better understanding of it. Execution. What is that? Oops. Hmm. Right, so this is where we I think create a task, the TTS task, and how do we actually run that? Hmm. So create a session options. So we create a task session. So I think that so yeah, I think this is happening over here. And maybe actually inference is happening here, right? I think so. What is this actually closing? Hmm. Alright, so I think this is where the inference is actually happening. Let's listen to to hmm. We're navigating the code base on this on NeoVim is kind of clunky because I really don't have an LSP for C++. So I'm not quite sure where the audio file is actually being written. But I guess it's somewhere here, right? And uh, there. Hmm. I could like to use fuzzy find it, right? Else, I could well, let me put it. I need to find search by. Yeah. So I need Ring. Hmm. Well, I think I need to do. Oh, this is- Hmm. But please don't tell me that, you know, well, that's not accurate. Yes, exactly. Does exist. Hmm. How about we open this in I really don't want to do this, but mm, no. Let's do some more play. There's no way I can't find this function. It's right there. Where the hell is this? Oh, wait. How the hell could I miss that? Like, man, I really need to. And what is the? What is this? What is the? So best LSP for Neo. He also has his community, so let's say let's see. Yes, not have. I don't think I have it. Let's see. I don't have. Alright. Okay. It's really good. How long is it going to install? Like, create the install. So maybe I will just what is this? Alright, so I guess we'll just stop it for now. Uh, we have been going on for a good 2 hours, so I think I need to get Clan D working. If I have to do, or maybe I could do it with Visual Studio. You know what? I think I will just stick with NeoVim, and I'll try to get Clan D working so that we can work with C code bases on NeoVim, and try writing. So we actually don't need extensively Plan D because we are not going to write uh, anything in C or C++. Instead, we'll just need the C code base as reference to understand how audio.cpp works. So we only need an LSP to that extent. However, it will always be a good addition to have a CLSP. So I'll try to get it working, and once we do that, we'll see in the next stream. So thanks for watching. See you in the next one.